Okay, students, we're now here at the last part of the Pythagorean theorem notes, and we're going to talk about the converse of Pythagorean theorem. So if you recall what a converse is, it's just when you swap the hypothesis and conclusion of an if-then statement. So typically we say if a triangle is a right triangle, then a squared plus b squared equals c squared. Well, if you're just presented with a triangle, you can do a squared plus b squared equals c squared, and if that's true, then it is a right triangle. All right, so basically this is you could write this as a biconditional statement if you wanted to. You could say a triangle is a right triangle if and only if a squared plus b squared equals c squared. You could do stuff like that. So what does that mean? Let's just dive in. All right, we have three side lengths. Does this make a right triangle? All right, remember the biggest side is always c. It told us that was c in this particular case. So this is what we're going to do. We're going to do a squared plus 15 squared. All right, and I'm just going to, in one single step, put that into a calculator. All right, that equals 289. I'm going to have 20 squared over here. I'm not going to write equals or anything. Well, what does 20 squared equal? 400. All right, those aren't equal. Hopefully you can tell that 400 is bigger than 289. All right, so it's not a right triangle. All right, so it's not a right triangle because Pythagorean theorem was not true. And if you remember, like when you do the Pythagorean theorem shortcut on a coordinate plane, we always draw a right triangle. We just don't draw some random triangle. It has to be a right triangle. All right, let's do this next one right here. All right, numbers are labeled, so we specifically know that one's C. Have 7 squared plus 24 squared. Let me compute that number. 625. Over here, I'm going to write 25. I'm going to square it. That is also 625. Those numbers are equal. So this is a right triangle. All right, so that's pretty cool. That you can just see side lengths. You don't even have to see the triangle itself, and you can tell if it's a right triangle or not. All right, so let's write down some generic rules really fast. What does it mean if a squared plus b squared does not equal c squared? Well, we already talked about that. It's not a right triangle. If Pythagorean theorem doesn't work, it's not a right triangle. All right. So if c squared is bigger, if this is the outcome, like we saw up here, this is actually obtuse. All right, so you can see three side lengths and you can plug it into Pythagorean theorem. If this is the outcome, it's an obtuse triangle. And the way I like to think about it, c squared's bigger, so the longest side is so long where compared to the other two sides, that's going to have to be obtuse. So that's like C, A, and B. This is just some generic picture, right? Maybe can help you visualize it. Similarly, if a squared plus b squared is bigger, then it's an acute triangle. And I like to think about this, well, now all the side lengths are pretty close together. Oops. All right, let's pretend I drew a perfect triangle there. That's A, B, and C. Not one is necessarily the biggest. All right, or they're pretty darn close. All right. So how much more problems? Oops, just a few more problems right here, all right? So, test whether or not the triangles are right triangles. Remember, again, I'm going to emphasize this a lot. Common mistake. A, B, those don't matter. C does matter. C has to be longest. All right, so I guess that you need to pick C first, and after you pick C, or determine which one's C, in this case 13.4, that's A, that's B. All right, or I could say 7's B and 10 is A. Regardless, so we're going to do 7 squared plus 10 squared. All right, and I'm just going to compute that number first, 149. Now over here I'm going to do 13.4 squared, which got a goofy decimal, so I have to use my trusty calculator. Hopefully my calculator didn't fail me. It told me it was 179.5, so that's bigger. So now I know that this triangle is obtuse. I didn't have to see an exact angle measure, But by using Pythagorean theorem and seeing that it didn't work, I can tell that it is an obtuse triangle. All right, now we got this bad boy over here. Again, the biggest one has to be C. A and B don't matter after that one. I'm going to do 6 squared plus 12 squared. 36 plus 144. And that'd be 180. Now in this case right here, we stole these problems, I think, from Gizmos. 13.4 squared is 179.56, but I think they were rounding. So it's about 180. So if we would have rounded, let's see, 180. This is why exact numbers can be better. 16407 or 86 ... That's a true decimal. For all intents and purposes, we can say this is a right triangle. It's pretty darn close. And in the real world, if you're this close when you're doing 3 side lengths, it's basically a right triangle. All right. So let's see. I like these 3 problems right here. Do the following lengths make a triangle? If so, is the triangle acute, obtuse, or right, scaling, isosceles, or equilateral? So now you can just be given a sequence of 3 numbers, and you can determine if those 3 numbers, if those were side lengths, if they would construct a triangle, and then you could classify it exactly. Like before I do any calculations, I know this is a scalene triangle. I'm going to write all different. They have all different side lengths. In case you forgot what scalene meant. Sometimes you guys forget what scalene and isosceles are. Not a big deal. I know you guys understand them. Just easy to forget. Now, which one's C? 6 has to be C because it's the biggest one. Let's do 3 squared plus 4 squared. 9 plus 16 and 25. Then we got 6 squared, which is 36. It's bigger. So this is obtuse. So by just seeing these side lengths, I know it's a scalene obtuse triangle. All right, and one thing I forgot to mention, and we're definitely going to see this in the future. This is probably what you should do first. Do you have to write this down every single time? No. But you should at least do it mentally. Make sure the 3 side lengths make a triangle. What do I mean by that? The 2 smaller sides, so like 3 plus 4 equals 7, which is greater than 6. This is the triangle inequality. We talked about this not too long ago. I can't remember. It was either right before e-learning or right after. Restarting. All right. So 18 plus 18. So remember, this is the step 1 you should technically do. I don't really care if you write this down for every step or every problem, but 18 plus 18, the 2 smaller numbers equals 36, bigger than 24. So yes, it makes a triangle. Furthermore, I automatically know it's isosceles because it has 2 sides that are the same. All right, now I'm going to plug it into Pythagorean theorem. 18 squared plus 18 squared is 648. 24 squared, I know it's not going to be equal. I can tell. It's 576. So this would be acute. All right, cruising right along. 6 plus 8 is 14 greater than 10. I can just tell this makes a triangle. All right, we don't necessarily don't have to write this down every single time. Remember, 10 is C though. It's not the last number. We have a habit of when we make these problems just that the biggest number is always last. In this case, the biggest number is first, so we have to do 8 squared plus 6 squared. All right, that's going to be 100. Let's do 10 squared over here. It's 100. Oh my gosh. So it's a right triangle. Wow. We finally found one. All right. Also, it's scalene because none of the side lengths are the same. So it's a right scalene. Powerful stuff right there. All right. And then this last one, really quick, let's take the two smaller sides. 6 plus 7 equals 13. To say that's greater than 14, that is silly. You can't even make a triangle with this. Not a triangle. All right. And just to emphasize things, if that's like saying, all right, this side length right here is 14. If I try to make a triangle with a side length of 6 and 7, they don't match up. They can't reach each other. They would collapse. Can't make a triangle. Is there any more problems? Oh man, no more problems. That's it for this video.